particular multiple choice question, we have a 1 meter board, which is this horizontal board here or beam here. It is tied here, 0.2 meters away from the left end by a string, and then it just kind of hangs there. It doesn't move, it doesn't rotate, and there is a hanging block of 3 kilogram on the left there. Okay, and it wants us to find what is the mass of the board, which is this horizontal shape here. All right, to do that, we need to set up torque. We need to set up torque because it's not rotating. It sets static equilibrium. So let's go ahead and do it. I'm just going to go ahead and set up the counterclockwise torque. It has to equal to the clockwise torque. And then before I do that, I can just go ahead and identify all my forces, what forces are present, and then what kind of rotation will it cost the system to rotate. Okay. So here, the block that's hanging on the left end of the board here is 3 kilogram. That's given to us. So the weight of it would simply be mg, and then m being 3 kilograms, g being 9.8. And this is just the magnitude of it, 29.4 newtons. And once again, we know the FG points down the page all the time. Okay. The other error that we need to draw out is the weight of the board. Here, this particular arrow orange here is placed at the center of mass. Or at the center of the board. I shouldn't say center of mass because you have a mass hanging on this side. The center of the board, f of g needs to be placed at the center of the board. Therefore, f of g board here is just mass of the board times acceleration due to gravity, which is 9.8. Once again, m board is what I don't know. Because I don't know it, I'm just going to keep it as my unknown because that's what I'm asked to solve for anyways. So here, if you look at this diagram, so you're going to tie a string right there. So for this system not to move, f of g due to the block here is going to cause a counterclockwise rotation, while the weight of the board itself will want to rotate in the clockwise direction. But both these things are balanced, so therefore it stays still. Okay, so I'm just going to go ahead and continue with my torque setup here. For things to be in static equilibrium, torque counterclockwise must equal to torque clockwise. Alright, I'm just going to go ahead and set this up. If you look at this diagram where my f of g here is in purple, f of g due to the weight of the block will cause the board to rotate in a counterclockwise direction. So you just have to visualize this left end going down and this right end going up. That's the natural motion of the weight of the hanging block. However, the weight of the board itself will want to cause the board to rotate in a clockwise direction. Once again, things balance out. Okay, so here I'm just going to go ahead and crack it out. F of G block we already know, which is 29.4. R block is actually given. So the pivot is at where the string is, and then from the pivot to where the force is being placed, F of G, that is the distance of 0.3. So I know all that. What I don't know is how far the distance is from F of G to where the string is. But I can just do a quick basic math here, right? And the center of the board is midway. So therefore, the arrow that just came up here, that would just be 0.5 meters because it says it's a 1 meter board. So half of 1 is just 0.5 meters. Well, here it's not drawn to scale. If this distance here is 0.2 already, well, the distance left over here that's going to come up in orange here, that would be 0.3, right? Because 0.2 plus 0.3 must equal to 0.5. So it's just a basic math here. If the distance from here to the center of the board is 0.5, and if you tie the string to where it is at 0.2, the remaining distance there would be 0.3. So that's where all this value is going to come up. So f of g, once again, I already calculated previously, is 29.4. Well, how far is f of g away from the pivot? 0.2. On the right side, it'd be f of g the board times r, but how far is it away from the pivot where t is? It'd be 0.3. Well, f of g is mass times 9.8. How far is it? 0.3 away. So really, if you look at the statement here, the only thing I have unknown is mass of the board. Okay, so I just do basic calculator work here. The left side will reduce down to 5.88. 9.8 times 0.3 will give you 2.94. So if we get m board by itself, divide both sides by 2.94, and then 5.88 divided by 2.94 will give you a value of 2 kilograms. And that is the answer for this one. Okay, all right, stay nerdy, don't be whack.